So when you're doing the sine law, there is a chance that you will have the ambiguous case. So when you have an obtuse angle, so we're looking for angle G. And in the picture you can tell that the angle is going to be obtuse. So let's solve to find angle G. So sine of G over our side of G, which is 10.8, is equal to, and we have our H, side and angle. So sine of H, which is 25 degrees, over 5.4. So we're going to multiply both sides by 10.8. So sine G is equal to 10.8 times sine 25 divided by 5.4. Then we're going to take the sine to the negative 1. This whole thing. And you should get the angle to be 58 degrees. We can tell from the picture that this angle isn't 58 degrees, because a 90-degree angle would be here. We know it's greater than that. So we know that there's an ambiguous case. So we can see that this is one triangle, and the other triangle will be the same as finding your reference angle. So 180 minus 58 degrees, and it'll equal 122. So we know that angle G is 122 degrees. You can also draw another triangle. So if we take this same triangle, we know that this side from H to J has to be 10.8 centimeters. And we know that it makes a 25-degree angle here. What we don't know is how long this side is. So we're just going to extend that all the way. And we know that 5.4 is right here. So this is 5.4. What can also happen is if we take this 5.4, the same length, and we drag it along this blue line, over here, it's going to touch again. It makes the exact same angle. So we found our angles to be 58 degrees and 122 degrees. That means that for this angle right here, this one is 122. But this one right here, that's our 58-degree angle. So this is called the ambiguous case, when there's two different triangles that can be drawn using the same set of measures. So to figure out if you have an ambiguous case, you can determine the number of possible triangles. So if you take any triangle, and you're looking for angle A, if you take your opposite side, so BC, and divide it by your adjacent side, so AB, we use this ratio to determine the triangles. So for example, one at the bottom. We have an 80-degree, and we have 8 over 5. If you take 8 divided by 5, you get 1.6. Because we know BC is greater than 1, it's going to be in this box, and what we have here is one scalene triangle. And what scaling means is that all the side lengths are different. For the example we just did, our opposite side is going to be 5.4, opposite the angle, and our adjacent side is going to be 10.8. And if you divide this, we get 0.5 So this is less than 1. Then if it's less than 1, we have to take the sine of A, which is the sine of 25, and we get 0.42. So we know that sine of A is less than BC over AB, which is our opposite and our adjacent, which is less than 1. So 0.42 is less than 0.5, which is less than 1. So we know it's this one, which is 2 scalene triangles. Our other options are, for the first one, if we find that our opposite divided by our adjacent is less than your sine of A, there isn't going to be any triangles, because there's no possible way to make an actual triangle from these values. If we find that our BC over our AB is sine of A, if we look at a right triangle, our opposite side is our hypotenuse, or from any angle. We have an O and an H. So if you were looking at your angle here, this angle is going to be our opposite divided by our hypotenuse, which is the same as your sine of your angle. So we know that when they're equal to each other, this is a right triangle. So you have one right triangle. And when you find that BC is over AB is equal to 1, that means that BC and AB are the same. So we have to have two sides that are the same. So that means you make one isosceles triangle. So these are all of our opportunities. So before we do a question, it's good to test how many triangles you have first. So if we go to example 3, we have a triangle ABC where AB equals 18.7, AC equals 17.9, and angle B equals 70. What we can do first is, it's always good, you can just sketch a triangle. So we have A, B, and C, and we know angle B is 70. That looks awful. 70 degrees. Let's put it in a different color. There we go. So angle B is 70, AB is 18.7, and AC is 17.9. So we want to find all of our missing lengths. So first, let's see how many triangles we get. So if we do our opposite divided by our adjacent, so it'd be 17.9 divided by 18.7, you should get 0.95. So we know that this is less than 1. So we need to check the sine of B. So sine of 70 degrees, which is 0.934. So we know that sine of 70, so 0.934, is less than our BC over our AB, which is 0.95, which is less than 1. So therefore, we have two triangles. So we know that when we find this, we're going to find one obtuse angle and one acute angle. So from the information we're given, we want to look for angle C first because it's opposite the other value we know. So we take sine of 70 over 17.9 is equal to the sine of C over 18.7 times both sides by 18.7, and we want to find the sine to the negative 1 of 18.7 times sine of 70 divided by 17.9. So that will be our C. If we type this all into our calculator, we should get C is equal to 79 degrees. So if we find that this is 79, we want to find our other angle. So angle A is equal to 180 minus 70 minus 79. So we get angle A is equal to 31 degrees. And our last step is to find our missing side. So we're looking for the side of A. So A over sine of 31 is equal to, we can use our B. So 17.9 over sine of 70. Multiply both sides by sine 31. And we get A is equal to 17.9 times the sine of 31 degrees divided by sine of 70 degrees. And you should get to the nearest decimal 9.8 centimeters. So we've solved this triangle, and it should look something like a 70-degree angle, so if this was A, B, C, this would be our 31, this would be our 70, and this will be our 79. Our B side is 17.9, our C side is 18.7, and our A side is 9.8. So we have one triangle that's solved. We want to also find the second triangle. So we're going to take our angle C, because angle C is the one that we're going to have to change. So take angle C, and we're going to subtract it from 180. So we're going to take angle C, is going to be 180 minus 79, which is the angle that we found it to be in the last equation. And we get 101. So this is going to be our obtuse angle now. So instead of having a triangle with a 70 and a 79, this one's going to have a big angle. So this is going to be our big angle of 101. And the reason why we use C to figure out our new triangle is because that's the angle that we solved for initially. Because we solved for C first because we know the other two sides. This is the angle that could also be obtuse. So we can find our angle A now. So angle A is 180 minus 70 minus 101, which is 9 degrees. So this one right here would be 9 degrees. This would be A, this would be C, this would be B. And we know that this is 70. And we have to solve for our sides. So we already know B is 17.9 and C is 18.7. So we need to find A. So A over the sine of 9 is equal to 17.9. We can do B over the sine of 70. We're going to multiply both sides by sine 9. So we get A is equal to 17.9 times sine of 9 degrees divided by the sine of 70 degrees. And you get to 1 decimal point, 3.0 centimeters. So we know this side is 3.0. So those are the two different triangles that we have. So one fire ranger station at A reports smoke 30 kilometers away in a direction east 30 degrees north at B. A second station, C, east of the fire station, reports the smoke 20 kilometers away. To the nearest tenth of a kilometer, determine the distance between the two stations. So the first thing we're going to do is let's just draw a picture. So we have one fire station and it's A. And we know that there's smoke east 30 degrees, so we're going over this way, and north. So our point's somewhere over here, and this is going to be B. And a second station, which is east, so this way. So we know that this is a 30-degree angle. This is our C. And we know from this point to the fire is 20 kilometers. So this is 20 kilometers, and from A to B it was 30 kilometers. So we want to know how far it is between A and C. So we want to find this value right here. So first, let's see how many triangles we have. So the sine of 30 is equal to 0.5. And our opposite side is 20, and our adjacent side is 30, which is 0.67. So 0.5 is less than 0.67, which is less than 1. So we know that there are two triangles. So we're going to have to find two distances, because there could be two situations from the information we're given. So to solve for this missing angle, we first have to find angle C, so that we can solve for angle B to find side B. So we're going to do the sine of A, which is 30 degrees, over side A, which is 20, is equal to the sine of C over 30, because we know our side for C. So we're going to multiply both sides by 30 and take the sine to the negative 1 of both, so sine to the negative 1 of 30 sine 30 divided by 20 is our C. Type this into your calculator, and if you do this to one decimal point, we should get 48.6 degrees. So now we know angle C. We want to find angle B. So angle B is going to be 180 minus 30 degrees minus 48.6, and we get 101.4 degrees. So we have our angle B. Now we can find side B. So B over sine of 101.4 is equal to A, which is 20, over the sine of A, which is 30. Multiply both sides by the sine of 101.4, and we get that B is equal to 20 sine 101.4 divided by sine 30. Multiply this out to one decimal place, you get 39.2 kilometers. So one possible answer is 39.2 kilometers. If we want to find our second triangle, we're going to take 180 minus 48.6, and we get 131.4. So for our second triangle, angle C equals 131.4, and angle B will be 180 minus 30 minus 131.4, which is 18.6. Now we use this B to find our other length. So B over the sine of 18.6 is equal to 20 over the sine of 30 for our a values, times both sides by sine of 18.6, and we get b is equal to 20 sine 18.6 divided by sine of 30, and our final answer should be, to one decimal place, 12.8 kilometers. So for our number 1 answer, it was 39.2, and our number 2 answer is it could be 12.8 kilometers away. So there's 2 possible situations that satisfy the given information.